Okay, to show why this property comes about the way it does, it's the product property. So what we have inside is we have two things being multiplied and in the argument. Okay, and so that's what we're working on, what that equals. To do this, to show you why this works, I have to set up some little assumptions here. So we're going to say that the log base b of m, just m, equals something. We'll call it a. Then b to the power of a equals m. So if you change it to exponential form. And then we're going to say, I'll just keep it in orange, log base b of n equals something. We'll call it c because we're already using b. So log, oops, didn't want that. Then if I change it to exponential form, b to the power of c equals n. Well, now what if I multiply m times n? Because that's what we have right in the argument up here. So mn is equal to b to the a times b to the c. But we know how to multiply when the bases are the same. You add the exponents. So it's b to the a plus c, right? Okay. So now I can use this to replace it into what I'm trying to find. So log base b of mn is equal to log base b of b to the a plus c. So I'm using all of this to replace the mn, the argument. Okay, but what did we just learn in our property 3, that inverse property? That if the base here matches the base in the argument, then it just equals, the whole thing just equals the exponent. So what does this equal? It equals a plus c. Okay, but now we have to go back to what were a and c. A was log base b of m, and c was log base b of n. And so my new property is going to say, this circle's a little bit in the way. My new property is going to say log base b of m times n is equal to log base b of m plus log base b of n. And that's the property, that's the product property. Now, if you want to think about it in kind of logically, what do logarithms represent? They represent exponents. And when you multiply, you add exponents. So I don't know if that helps, but I kind of think of it in those terms. So you can split up the multiplication into addition. Now, back when logarithms were invented, I would say, that was very useful because they didn't have like handy-dandy $15 calculators. It was much easier to look things up on a table and add these 4-digit decimals to each other rather than trying to multiply things and then take the logarithm of that. Okay, so it saved some work in calculations. We use these properties to do different things in other areas now.